So hello everyone, coming to the final subtopic on the chapter matrices, that is system of linear equations. Now this is, I would say, one of the applications of why we had studied matrices. So until now we have been seeing what a matrix is. We first looked into the introduction of matrix, what a matrix is, then how it's represented, how the data is represented, how the positions in a matrix are represented, and then how matrices are classified, and then what are the various operations possible on those in these matrices. Then what are the basic rules for every particular operation, what are some various properties for those operations. We've seen a lot of things as far as studying matrices is concerned, but this is the first time we'll actually look into where these matrices can be applied. So let me set some context for you before we enter system of linear equations as to how matrices will be helpful here. So in your 10th class you would have already studied something like this. You have an equation 2x plus 3y is equals to 1 and 5x plus 7y is equals to 2. If you have these two equations, there are numerous ways in which you can solve them. First of all, you guys already know that these can have a solution. So basically x and y are your inputs to this system. So this is a system, this is a system of equations. You put an x in this and you put a y in this, you put them as a pair and see that this is satisfied. You will always find at least one x or y which will satisfy this, but there is no guarantee that the same x and y will satisfy this, right? So we need that x and y which will satisfy both this equation and this equation, right? So that is why this is called a system of equations. And through the system what you pass is your xy, which is your input, and if it satisfies both, then I would say okay, it was a valid input. So we actually are looking for that x and y which can satisfy this. That is what my job is. So in your lower classes you would have studied various methods, elimination method, substitution method, where what you can do is you can separately get x from here, which is 1 minus 3y by 2, and you can put this x in the second equation and get what y is, and then finally get what x is. You can do all that, right, when you have two equations. But for instance, what if I give you three equations like this: 2x plus 3y plus 7z equal to 2, 5x plus 8y plus 9z equal to 1, and 2x plus 4y plus 3z equal to 0. If I give you three equations now and ask you to do the same thing, get me that x, y and z, like that triplet, basically that triplet which can satisfy this and this, all these three equations simultaneously. So here is my system. Here is my system of linear equations, and I'm looking for that x, y, z which can satisfy all these three together, right? That is what my motto is. Now here also, it's not that you can't solve this if you don't know matrices, right? You can always do that. What you can do is you can solve these two to eliminate z. You can solve these two. First you can solve this and this to eliminate z. You can solve this and this to eliminate z. Then you will have two equations with only x and y, and then you can solve those two separately, get xy, and then finally put xy in any of these three and get z, right? That's a very lengthy method. You can always follow those eliminations and substitutions that you've already known. But as the number of variables increase from 2 to 3, it gets even more complex. When it goes from 3 to 4, it gets even more complex to use those old substitution methods. That is where your knowledge of matrices will come into picture. So let's actually now look at how the knowledge of matrices will help us solve this system of linear equations.